There we go. So, Craig,
Dan.
the other day you got a little bit of a freebie treat from a buddy named Peach,
Yep.
and it was a what now?
It's a LED sign. It's one of those
Okay.
has all these little LED modules in it. Well, here, all these little LED modules in it,
Yeah.
and just it has a bunch of shift registers in it. And the idea is it's a pretty old school sign. It sounds like those old LED signs you see in like a gas station window, and it would just sit there and just cascade all the letters down, and that way you could print words and stuff on it. So
Yeah. So it's a marquee sign.
yes, exactly.
Okay, it's an LED marquee sign, and this sign had a whole bunch of weird electronics that we didn't want to try to interface with, and besides, we didn't want to play with the sign anyways. We wanted to play with the LEDs.
Exactly.
So we took the sign apart.
Very apart.
There's no video for that, so
Nope.
sorry. But we did get that apart, and
Yep.
we discovered something really cool. All these little LEDs are actually in what's called a matrix, and in this particular case, it's a 5x7 matrix.
Yep.
And we're going to go ahead and let them see the 5x7 matrix here real fast in our ghetto screen capture of our circuit board. And you can actually see the matrix right there, and it's printing letters, okay, which is what it's supposed to do. So the other day, we go ahead and we start desoldering these modules off there and the shift registers and all the various little bits.
Yep.
And we get it all broken down, and we forgot the USB cord.
Yep.
So we kind of just twiddled our thumbs and lit up LEDs analog-like. We didn't use a shift register because we had no way of programming the Arduino to handle the shift register. So we just kind of made it happen whichever way it
More or
worked.
less to just check the letters and
see
if we can. All right,
light all
here's
the
the
LEDs.
pins, and all right, let's light a couple of them up and
See if it'll light up.
Make sure we kind of got the basic idea of the matrix out.
So we went ahead and did that, and
Which, by the way, the LED matrix has they come out from hell.
oh my goodness, it is horrible. It is horrible.
It is horrible.
Horrible. There's no rhyme or reason to it at all.
No.
Actually, it's quite random.
All right, row 1, pin 14. Row 2, pin 2. They're on opposite sides. Why?
So we swallow our pride and we go ahead and we basically stare at this thing for a little while until we can all appreciate how the actual matrix works. We then took our Arduino, and at about 1 o'clock today, it's just going on 6:30 now.
Yep.
We ended around 6:30, but at 1 o'clock I got here and we had all the hardware and we started development because we remembered the USB cord this time.
Both of us did.
Both of us had USB cords this time. We found out a couple of things. It went through a couple of versions before we finally picked a circuit that would work. And I'm going to show you guys the circuit now. And Craig's going to disappear off the frame while we take a look at it. Up here in this corner is the shift register. You're not going to be able to see it. I can't let you see it. It's cluttered. But the shift register takes power and ground and 3 pins from the Arduino to work. Latch, clock, and data.
Yep.
At this point, the shift register goes through a series of current limiting resistors and then down into our LED module here. At this point, it comes over here, and each of these NPNs will switch on the ground for a corresponding row, okay? And that's done from the Arduino here. So the code simply turns on the ground for a certain row, and at the same time, we load the binary into the shift register to tell us which lights on that row to light up. Oddly enough, the way it works, I think it's just a problem of using the wrong pins in the shift register. I don't know. But it actually starts on this side, and it counts, oh, my finger's off the board, 2, 4, 8, 16, 32. So if I want to see the light on what would be your all's right light up, I have to send it a 2 to the shift register. If I want to see the light on the opposite side, I send it a 32. If I want to see both lights on opposite sides, I send it a 34, 32 and 2. And that's how that's working. At this point, we created a series of arrays that hold the letters for Hello World. And we then loop through the certain letter for a certain duration of time. We print a blank character, and then we loop through the next letter so that we get that persistence of vision thing. The really cool thing about this is none of these LEDs are on and staying on. They're actually flashing really, really fast, and they're using persistence of vision to light up and stay lit up. Right now, we are essentially done with prototyping. We got to refine our code a little bit. There's a slight problem with row 7. It's kind of faint.
Yeah.
And then we also have to figure out how to link multiple devices together. We gotta use the data in, data out of the shift registers and create a big long chain of it. The Geek Group has a blinking lights project that Paul Kidwell worked on and is working on that does this exact task. And I've been talking with Paul today to solve some of my various little problems, and we got to where we're at. So I'll be sitting down with Paul, and we'll be figuring out how to link multiple of these LED matrices together. At that point, the plan is to take the matrices and head out to a Salvation Army, buy a coat, mount the matrices on the coat, and we're going to call it the
Alphabet Soup Suit.
The Alphabet Soup Suit. So essentially what it'll do, and it's dork to the nth degree, it's geek to the nth degree.
Oh, yeah.
But what it's going to do is there's going to be 6x2 characters on the chest, basically 2x3 on each side over each pec, and then on the back it's going to be a 6x6 character display. And we will. I had an idea about this. You haven't heard about this idea, so Craig's finding out about this off the fly because with something like this, it grows on you and it grows on its own. But my idea is to take a glove and you close your thumb and your finger together, and depending on which finger you're engaging, there will be a resistive wire of different resistance, and that will hook up to the Arduino. And so if somebody asks you a question and you want to respond yes, you close your fingers together. If you want to say no, you close the other 2 fingers together. And what'll happen is the Alphabet Soup Suit, up to that point, will be randomly displaying letters to random modules for random intervals. It'll be Alphabet Soup. But when you actually trigger an event by closing your fingers together, you can trigger a certain set of letters to show up in a certain position, so that somebody says, hello, have you had a nice day? we got to come up with a way to give them the finger. We got to put some pads on the bottom of the palm so you can close and give them the finger, and it'll say "fuck you."
That would be great. That would be really great.
So this is essentially the Alphabet Soup Soup. It's still in its infancy. There's still a lot of work to be done. We still got to go find the code. We got to figure out how to link shift registers together. We got to refine the code. There's a whole bunch of code that's not even been written. The random letters to random positions thing hasn't even been realized yet.
That's going to be
it's going to be a nightmare.
Yeah, it's going to be a nightmare.
It's going to require alcohol.
A lot of alcohol, and I'm feeling a big whiteboard. We can go, draw a lot of arrows and circles. And
We're actually going to draw out the program logic, you think?
Might have to.
Well,
no, I'm just saying. All right, so now this piece talks to this one and this one over here, and by the end of it, only we will understand it, and anyone who looks at it would be like, I don't even know.
The suit's going to be the Alphabet Soup Suit, and the code is going to be nicknamed Spaghetti.
Yeah, exactly. It runs on the spaghetti engine.
So there you go. There's the Alphabet Soup Suit. You're up to date. We're up to date. We're up to speed. And we're moving along pretty good here.
We are actually, yeah.
A lot of people are looking forward to this. This is a neat little herpaderp project that really has no meaning other than just to see if we can do it. And it's really trying some of the limits of our experience with the Arduino and with hardware and making it all talk and making it all work together.
Either of us have you ever used a shift register?
I've never plugged a shift register in and tried to make it.
I hit up a circuit for it once to test out with the Arduino, but I didn't have my USB cord with me, so and I can't program it.
Yeah, that's not gonna happen.
I spent like a good 30 minutes.
No, that's something very interesting. I'm going to be talking to Captain from the Geek Group, and I want to do a series of Arduino videos on the actual Geek Group official, where we start with, this is the Arduino, like do an unboxing. And then the next video, we're like, okay, let's make pin 13 blink.
Yeah.
You know, and I mean, literally go right through the tutorials as they're written on the website, but do a quality video for each one, so that if there's any question, we can say, this is how this piece works together, this is how you find information, this is how you wire it together, and this is what it looks like when it's done.
Right.
And that way, people who are doing what you and I are doing will have a resource to know that, oh, by the way, you have to have that one pin hooked up on the shift register for it to work at all.
Yeah, that was definitely a problem.
That was a bit of a headache.
Yeah, that was. Why isn't it working? I don't know.
I don't know. Portugal. That's why Portugal. So that's everything, guys. We'll see you next time with the next update.
Yep.
And hopefully we'll be sporting our new coat around. So we shall see.
Yep.